Hello viewers, welcome to video number 69 of the channel Chemphilic, and video number 69 is the 11th episode of Chemical Thermodynamics, and the topic of this 11th episode of Chemical Thermodynamics is First Law of Thermodynamics Part 2. Part 1 in my previous video I have discussed, and in part 2 I will discuss about some special forms of first law of thermodynamics. So let's start. See, from first law of thermodynamics in my previous video we have seen that heat absorbed at constant pressure goes to increase the internal energy of the system plus the pressure volume work done by the gas. So here we have taken heat is absorbed at constant pressure and then it is divided into two parts. One part increases the internal energy. That means it increases the thermal energy. Therefore, the temperature increases. Increase in internal energy means increase in the temperature. Plus another part, it performs the pressure volume work. And then we have seen that this is equal to delta H. That means the change in the enthalpy. Enthalpy change means change in the total energy content, and enthalpy H is equal to E plus PV. E is the internal energy, that is the inherent energy of the system, or that is the energy which depends on the chemical nature of the system, that internal energy, and that indicates the this indicates the thermal energy. Okay, increase in internal energy means increase in temperature. So enthalpy is equal to this thermal energy, that means internal energy, plus this energy of this pressure volume work. That means it's the total energy content of the system. Okay. So heat absorbed at constant pressure goes to increase the enthalpy of the system. That means change in enthalpy is nothing but the heat absorbed or heat released. So change in enthalpy equal to heat absorbed when you are giving heat to the energy, or when the heat is released from the system, then change in enthalpy will be equal to the amount of the heat released. Okay. Now let us discuss some special topics on this first law of thermodynamics, or special forms of this first law of thermodynamics. Okay. Now suppose at constant volume. At constant volume. Constant volume means volume is not changing. So delta V is equal to 0. Just imagine constant volume, heat is supplied. That means heat is absorbed by the gaseous system. Now QV, heat absorbed, here I am considering the absorbed. Heat absorbed at constant volume, that is equal to delta E, and it is delta V is equal to 0 means this part is 0. So what we can conclude? When heat is absorbed at constant volume, it will increase only the internal energy. Entire absorbed heat goes to increase the internal energy of the system because there is no pressure volume work. Similarly, heat released from the system at constant volume, that means it will decrease the internal energy of the system, and there is no question of any pressure volume work. This is first case. Now in the second case, say just imagine that isothermal process. Isothermal process. Isothermal process means delta T is equal to 0. There is no change in temperature or temperature is constant. Now then if heat is absorbed but temperature you have to keep constant, then internal energy is the function of temperature. Already I told you internal energy indicates the thermal energy. Internal energy increases means temperature increases. So when temperature is constant, then there will be no change of internal energy. In that case, your delta E will be is equal to 0. No change in the internal energy because temperature constant. Internal energy is the function of temperature. It is the thermal energy. So change in internal energy means change in temperature. Temperature constant means no internal energy change. In that case, heat absorbed will be is equal to only the, here I am considering absorbed. So heat absorbed will be is equal to only the pressure volume work done by the gaseous system. So entire heat absorbed will be equal to the pressure volume work done by the gaseous system in case of isothermal process. Okay. Now coming to the third case, that is adiabatic process. Adiabatic process. Adiabatic process means system is kept insulated, and in that case Q is equal to 0. That means no heat can enter to the system, no heat can released from the system. So now coming to this case, that is when Q is equal to 0, and that is your is equal to delta E plus P delta V, that is the pressure volume work. In that case what will happen? This pressure volume work done by the system, that will be done at the cost of its own internal energy. Therefore, internal energy decreases. System is doing the work. Gaseous system, just imagine it is pushing the piston. It is undergoing expansion. But for that it needs the energy. But no heat is supplied to the system. It is completely insulated. Then from where it will take the energy? It will use its own internal energy to perform this pressure volume work. So internal energy decreases. Internal energy decreases means temperature decreases. Okay. So these are the some special forms of first law of thermodynamics. Hope you have understood. Thank you.